But let's jump into a section now on the containers and how did we make all that possible? So it's super nice that we just said with Docker, and we were able to do that, but how does we kind of build that ourselves, and assuming that we didn't have, even like sort of assuming we didn't have Nextflow, what it would look like. So containers are a kind of a key part of making all of this possible. And we saw before that their example compared to like virtual machines, which people were previously using, the containers are much more lightweight, they're much faster, we can spin them up. We can also just reference them really quickly. So we can say, use container for this. And there's some really great resources, things like biocontainers, but we can also leverage things like Conda to access and really avoid having to install software ourselves. Because you're probably very familiar with the fact that often when you start a new project or you go start to run someone else's work, it really feels like you spend half the time just setting up, installing the software to make it happen. And really containers get rid of all of this and get rid of all this pain for us in most cases. So in our case, we're going to start with the kind of basics. Now, this is not specific to Nextflow. This is like a section. So if you're already a container guru, this probably next 45 minutes or so not going to be super essential. But I'm going to kind of start from this and assuming that you kind of go through the basics of it because it's kind of important for working the way we do. The basic ways of doing this, the basic ways of running it, it's a little bit like Nextflow, and we're going to use Docker here. The same principles apply to many of the different container engines. There's some subtleties. We'll show you some difference of Singularity later on. But in terms of building and manipulating containers, Docker has become like kind of a standard to a certain extent in terms of the way that the containers are used. It has really fantastic tooling for creation, for registries, for being able to kind of build those containers themselves. So we're going to start using Docker, but again, keep in mind that the technology is kind of common across all of them. And we have the kind of basic ways of running this. I'm going to close out my terminal here, and we can just say from our container, and you can do this yourself. We can say Docker run. And the first thing I'm going to do is just run hello world, a little bit like we did with Nextflow. And when we run here, you can see that what's happened is that hello world, the container was not available on this machine. So a little bit like how we just ran GitHub, you can see that we've pulled this from remote. So essentially this is from a container registry. And this is kind of showing us what happens when you run Docker. It's a help message linked in with a hello world. And Docker runs slightly different than a kind of standard piece of software. When you run a standard piece of software, you might have like an executable file, a binary, which you will run. Docker has a kind of two parts to it. There's like the client, which we are using here when we say Docker. This is the client. And then there's also the kind of service, the daemon, which is running on our machine. And this is one of the reasons why Docker is not really used in shared environments in terms of the actual execution, because it means you can elevate your privileges using the daemon in certain situations. So what's happened is we are running Docker. We say Docker run, and we say hello world. The client, so this command line, interacts with the daemon, which is running on your machine as well. It's all running inside this virtual machine. Then it's going to say, is there this container here, this hello world image? Does it exist? No, it doesn't exist locally. So I'm going to go to Docker Hub, pull that container there. And then when it's running, the daemon itself is going to basically take that image and it's streaming the outputs to the client, which is then placed in the onside of our terminal. So we can see that this is the kind of steps which is taking place when you're running the container. There is this kind of automatic way of connecting it with your local system, seeing if that container exists, if not pulling it. Once it's been pulled, then streaming the output and interacting in this way. So it's kind of basic enough. It's just like running the containers. We can also pull them. And this is kind of similar to kind of cloning a repository or something, but I'm just going to say Docker, in this case, pull. And here I'm pulling a container image that I want. So we're going to be using as our base, as essentially our test image here to start, Debian, so flavor of Linux. And we can specify the version on here. And the way this works is it's typically the ID. So Debian is just a vanilla image that's just only got sort of Linux installed. It's basic. And this is the tag or the version. So this is the version of that. Those tags can be defined however you want. When I pull this now, you can see it's going to the library for Debian. You can see that it's pulling this, and now it's available on my local machine. We can see that by seeing Docker clear images. And now we can see all of the Docker container images that are available on my machine, the kind of ones that are local to me. You can see that we have the Debian one we just pulled. can see it's about 55 megabytes here. You can see there is the hello world example, the one that we just ran previously, which is like 13 kilobytes here. And then you can see finally we have this RNA-seq pipeline, which is the RNA-seq container, which is what we were running before. This is the container which has got Salmon and multi-QC and fast-QC installed in it for us. And you can see that it's quite a bit bigger. It's about 2.5 gigabytes there in terms of the way it's run. So we can see how we can take the container, we're able to run hello world. How do we actually do something useful with it? How do we kind of see what's happening here? So first thing I'm going to do is I want to consider how I can interact with the container. I want you to see when I go here, I'm going to say Docker run here. And there's a command that you can use, which is -it here, which allows you to interact with, essentially jump into the container itself. So I'm going to jump into Debian here. This is the same one that we've got. So I don't even think I need to specify the version here. And then I'm just going to say, well, what do I want to do? I want to run bash inside there. So kind of going inside there. Actually, I think I've pulled the latest version, but it should be the same. Okay. What I want you to notice here is this section here. Notice how before I was user 522, you'll be your own user. Now I've changed the user. Now I'm actually root. And the reason for this, I'm actually inside the container now. If I do ls, you can see that this is the file system for the container. If I exit out again, you can see I'm back there. So when you're jumping into the container, you really are going into a complete new environment. And all of the kind of setup for that is completely dependent on the container itself. And this is going to present us with quite a few challenges as we go through in terms of setting this up, and particularly if we want to do things like some bioinformatics workloads against this as well. So let's start with this and start to think about how we can build our own container. We're going to build the container that we used for the RNA-seq pipeline. And how we can kind of build that up. Well, I'm going to create a directory here called Docker. And this is where we're going to build our container. And inside this container, we're typically going to have what's called a Dockerfile. And the Dockerfile is the definition, essentially the recipe, the rules for doing that. So like before, I can even do this by, if you're comfortable using something like Vim, you can create the Dockerfile. I'll just show you on the screen. For doing this, I'm going to create a new file here, and I'm going to save it as inside my Docker directory. And the important thing here is actually has to be called Dockerfile. It has to be called Dockerfile with a capital D. This is following like convention, things like make, where you'll see like the make file with a capital M. So we've got Dockerfile with a capital D here, saving it inside of this Docker directory. And now we can start to write the recipe, start to write the instructions for how we're going to build this out. So let's start with base image here. And if you look at the instructions on how to do this, in terms of the container, I'm just going to copy paste, but the containers have got layers to them. And what I mean by that is that each of these lines from maintainer run here is a layer in the image, and there's an order to them as well. So you have the from, which is run first, and then on top of that, you're adding maintainer, it's just some metadata. Then we have the third layer here, which is a run command, essentially installing some software. And the final one, we have an environmental variable we're changing, so we're changing the path in the container itself. This is super useful because it means that we can start with a base image that maybe is something useful we want. Like if you have already a container from someone else, you can use this as your base, and then you can just add your software on top of it. But you can also kind of build from very small, minimal images. Sometimes you want to have a very small container for passing around optimized images, etc. Images for different architectures. At the moment, we're just running on sort of Intel architecture, but if you want to run with different ones, you can also kind of use that. So our base is basically starting from this Debian basic image, the one that we pulled before. You can add in here your maintainer if you want to put your own name in here. And the key point is that we are running this command here, which will install, first update, and then install two pieces of software. The first one is curl, and the second one is cowsay in the container. And then it's finally going to change the path. So if you save that and that's acceptable, I'm going to go cd into Docker here, into my Docker file, my Docker directory. And then I'm going to run the command to build the container. This is Docker build, MURL, this is D. And then we want to specify the name, essentially the tag of the container. In our case, we're just going to call it my image. And then we're going to specify the dot. And the dot here is important because it means in this context, basically build from this location, and it's going to look for a Dockerfile in this directory that we have. So let's start with this, and we'll see it go through the process. And you can see from the top, we've got the 4 steps. So step 1, building from this base container. Step 2, which is the maintainer. Jumping on me. Step number 3, which we had, which was running this apt get. So it's going to take a little while. And then step number 4, which is changing this environment variable. This container is now successfully built. So we've built our first container, and we can see that by saying Docker images, and we can see we've now created this new image, my image, which is available here. 19 seconds ago, 130 megabytes. Very cool. Now let's think about how we can use this though, and how would we use the software we've just installed. Well, we don't have, for example, Calce, the application here that we just installed. We don't have it locally. Exactly like we didn't have Salmon installed the other day. But we can start to use that. We can kind of go into the container to run that. So we could say Docker run here inside, and then I'm just going to say interactively into this new container we've just built, which was called my image. And when we jump inside here, we can see that we've got Calce. So if we do something like Calce, hello Docker, you can see we get this image. And this is just an application which is used for teaching and for training for containers. So the application is installed. We've got it in the container. We're happy with our container for now. Let's try and add something a little bit more useful to it. At the moment, we've just got curl and Calce. It's not super practical for a kind of our Salmon application that we want to use. I'm going to exit from the container here, and we're just going to add in a single line. We're just going to add in a new command. And it's important that we want to add this in after the current environment variable here. And what we're going to do here is we're going to take commands. You can see this in 4.1.6 of the docs. So the exercise here. So I want you to copy 4.1.6 and copy this in here and paste this. And then I want you to try and build your own image there using this one as well as the original Dockerfile here. Okay, so I've added that line in there as the 5th of our runs in there. And the way this works is it's a little bit like Nextflow's caching. When I launch this and I say, I'm going to build everything exactly the same, so Docker build, you can notice that the first 4 of those steps are cached, and the 5th one itself is running. So it's only having to run the final one here. And this is just going to GitHub. It's taking Salmon, the version of Salmon there, it's extracting it, and it's placing it on our path so that we have Salmon installed in this container. When you look here, the one thing to point out is that if we say Docker images, you'll see that we've just got this latest tag, so my image tag latest. And this means that we've essentially kind of overridden the previous container image that we have. You can change this by adding different tags on this. So if you wanted to say the Docker build my image and you wanted to say version 2, whatever version you're creating here, you can see that now we've created a tag of that. If we say Docker images, we have both latest, which is the default one, just the latest one gets added on there, as well as the tag. And you have to be kind of, when you do this, you should consider a little bit about how exactly you want to name them or how you want to link them in. It's very kind of common best practices to have these containers built automatically. So you can have like a GitHub action, which will take your pipeline and any containers, anytime it basically can scroll through the Docker files and build those containers on the fly, place them in a registry. And then you've kind of removed any potential for kind of messing up in terms of the reproducibility and which versions of stuff that you're running. But in our case, it's kind of going back to the point, we now have this new my image container image, which contains Salmon inside it. And we can start to run our pipeline. We can start to think about how we can run our quantification step that we have. So the kind of first approach would be to kind of firstly see that we have this working. So let's just say Docker run interactively, remember, and then we're going to say my image. And if we go into here, you can see that we have Salmon installed. So it's working for us. That's kind of a good first step. If I exit out, you can see that I don't have Salmon inside the system, inside my host system as well. So that's kind of working in that regard. Now, what would be the first thing that we want to do? So we imagine that we wanted to replicate script number 2. So script number 2 has a single process, and it is just running this command here. Salmon index has the threads. We can ignore the threads for this section, and we're going to specify a transcriptome as an input, and we want to get out an index from the end of that. So how could we go and replicate that? Well, the first thing that you might consider doing, I'm just going to cd back one, so I'm in the same base directory where all my data is. I could say Docker, in this case, I would say Docker run. And the first thing I'm going to be doing is saying my image, so the thing as we had before. We're not going to be using interactive now because we don't want to go into the container. We actually want the container to do the work. Once you've specified my image, we're going to say, what's the actual command that we want to run? Well, this means we can basically kind of copy paste this. So we can say, okay, I want to run salmon. And the commands for salmon then are, typing's not very good today. So Docker run my image. That, and then I'm just going to specify here that's going to run salmon. And then you're going to choose exactly the location of this transcriptome file. So -t. In our case, we have to specify the full path here. So we could say pwd, just because it's going to be, we see this as mounted in the container, but data, essentially here. And then we have our gggal, and we have transcriptome. Okay. We want to get out of this an index. So I'm going to say -out, and I want to create an index from that. So hopefully you can see that it's a pretty much a one-for-one of what we had before. If we remove the threads, Docker run the image salmon, and then point to there. When we run this though, see what happens. You can see that it's run. So you can see salmon is running. So it's like we're launching from the host. The container is coming up. It's presenting for us this message though. And if we read it, the final error here, it says that this file, this transcriptome, does not exist, which is kind of weird because if we look at this path here, we say ls on data here, and we see inside of it, we'll see that the transcriptome file does exist. And this is the problem around the file system. The container has its own file system, and when we launch from here, from our host, that doesn't have access. The container doesn't have access to that. So one way we can get around that is by, when we're running the Docker commands here, is to specify what's called a volume mount. And we're going to mount our input data, in this case, our transcriptome, inside the container. And I'm just going to copy paste this because it starts to get a little bit long to write out. But the main steps here you should be able to see are the exact same command. We're just mounting, we're adding an additional command here for volume. So we're saying Docker run, we're mounting our transcriptome inside of the location. So basically in this case, in the root path. And then we're running salmon index with everything else the same. And you can launch this and you can see that it's run successfully. So now you can see that we've ran salmon inside of that container. And that's launched, and you can see it's kind of getting this output. It looks pretty good. And you must be thinking, okay, that wasn't too difficult. But let's consider now our output. We were trying to generate this transcript index. It's the output of this. Where is that gone? Oh, that's here. I don't see anything. And the reason it's gone, the reason why you don't have it here, is that the output file, the index we just created, was only existing inside of the container. The container's gone. Kind of shut down as soon as that task is finished. And now we've lost our files. So this is kind of, again, it's not something that you'd want to be kind of doing here. One way you can get around that though is by mounting not just the input file, but what about if we mount our whole working directory or our home directory? In this case here, you can put in there all inside the container. And that means when the container references it for input files, but also any output files that are created can be seen, essentially can be seen from us outside. And I'm just going to copy paste the next command here, which is doing the exact same thing. It's just mounting now our whole home directory as well. So just paste through here. So Docker run, mount the home directory, specifying that we're going to run from here, PWE, from this location, using my image, run salmon index, and here we're specifying the input of which is that, and this is the output we're trying to find. So run through that. Fantastic. You can see this is running successfully. This is run out. And the thing that we're looking for now is, if we do it on here, we can see that transcript index has been created. So that's great. So now if we do like ls on transcript index, we can see, hopefully, it's our files there. That's exactly what we wanted. But there's one problem still. If we consider, if we look at here and we look at what we just created, all of the files so far that I've been using, everything I've been creating has been under my user, EC2 user. This is like my Unix user when I'm using this virtual machine. Now you can see that transcript index got created by root. This obviously creates a bit of a problem because us as users in the host, like, you know, as a user in this host system now, I can't actually change that file. I can't move it. I can't remove it because I don't have permissions. Essentially, it's not my file anymore. And this comes to some of the problems around using Docker in shared environments. It allows you to elevate your privileges to root in this case. So Docker is fantastic for building this, for running the cloud, for building the containers up for the tooling, but in some situations, this is not going to be appropriate for this. Now, in Nextflow, there's some options for doing this. And if you think back to our Nextflow config at the very beginning, we had this Docker run options. This is a way of specifying that the user, when you run Docker, is the user of the host. It's essentially just a variable here. And the group is the group of the host, not the user of the inside the container. So this is something that you'll often see. There's also a variation of this as well that you'll often see for running with containers. And it basically means that when we run this, we can either add this as an option in Docker, but Nextflow takes care of this and running as well. So kind of a long-winded way to say, don't do really everything I've just shown you now. I'm trying to demonstrate here the use of containers, but having to write out this whole thing that we just did for every command is not going to work. It's going to be completely unscalable. And we have to think about here mounting all of the volume, creating this location, making sure that the files are there. This is kind of really not the right way to do this. So obviously, when we think about when Nextflow runs this, we can say Nextflow run in our case, and we can say script number 2, and we can say with Docker, let's use now the image that we just created. So we created our image. When we launch here, we're launching the script number 2. And you can see that's already completed. But what's taking place, and I showed you a little bit of this yesterday, if we go into the working directory here, if we do a cat on the work, C1, D, etc., and we look at the .command.run, you'll see that Nextflow is really taking care of this for us. Nextflow has taken our command. It's running it as a Docker run command with one CPU. It's mounting our environment, mounting our working directory. It's also mounting the work directory of where the task is living. It's also doing this user transformation in terms of the namespace there. It's running this container image, and it's placing this and then essentially launching the .command.sh, which is the actual thing that we want to run here. And all that. So yeah, a long-winded way to say don't do this, and a kind of long-winded way to say that Nextflow can make containers really easy to use because you don't have to handle all of it. At the same time, it's useful to understand exactly what's taking place behind the scenes and how it works and how you can hopefully build your own containers now to use these things as well. Another thing to point out that can be interesting in terms of when you're using the containers, so far with the container that we ran was just local. So if we say Docker images here, you can see that the one that we ran was just locally. It doesn't exist. So if you try and run my image now against my one here, it's not going to work for you because your one's that's basically not available remotely here. But what if I could make that remote? What if I, just like I can publish my code to GitHub, what if I could publish my containers into a registry? And this is exactly what things like Docker Hub exists, but all of the main cloud providers have got their own container registries. You can spin up your own container registry as well if you want. If we go over to something like Docker Hub here, and we log in, you can log in here with your credentials. You can sign up for this. And when we sign in here, where's that one? Here you can see a whole bunch of different containers that I've built. But what's possible and what's kind of more interesting here is that if I say here Docker login, and again, I just have to sign in quickly. Try again. Now we can take the container that we have and we can push it to make it remote. So now I've logged in here. So I can create the container that we've got. So Docker images. I want to say, the first thing I have to do is I have to give it a tag. And the reason is that this tag is not enough of an identifier for the whole world. Obviously, it's not going to, I have to specify the user as well. So we can say Docker tag. I'm going to give it what we're starting with, so my image, and I'm just going to place it inside of my container registry. So floating-image, that's my image. And then we can even give it a tag if we wanted. So we could say like EDI training. Okay, so that's the top, that's given it a tag now. And now the next thing I would need to do is to push this to make it public. So Docker push. Pushing this image now. Now, if you would go run your pipeline, as soon as this is done, you can say Nextflow run script 2 with Docker, and you could paste that in there. And then you start, and then instantly you can run with basically my container. Very easy way to share the kind of software, to share the whole containerization aspect of it as it links in as well. So very useful tool for that regard. If you want to go back kind of deeper into the reproducibility angle, if you notice here that when we're running this, let's go back to example with here, we're just saying my image. Now, maybe it's not necessarily the most reproducible thing because you can overwrite my image and you can even overwrite the tag. So I could even create like 2 versions of version 2, which is not going to be ideal for when you run this. But if we go back to the example before that we just ran, when I push this container, you'll see that you get this digest. And this is a hash of the whole container itself. And what this means is you can define, and from Nextflow as well, this hash to use for that container. And it means that the whole container is fully reproducible, that there's not a single like byte that's changed inside that container. Otherwise, this hash would be different. So again, it's another way that you can confirm the kind of reproducibility of that as well. And kind of all links in there as well. Okay, let's have a little look at some of the other ways of running with containers. And I say Docker is typically used, I use it mostly for building those containers. Obviously, when you're running in the cloud, most of the services like AWS Batch and Google Life Sciences, Azure Batch, they all run with Docker containers. But there is alternatives to Docker, and there's a lot of interoperability between them. So I can build a Docker container and Docker, I can push it to Docker Hub, and I can have Singularity pull that and convert it into a Singularity image to run there. So important to keep that in mind. It's not one or the other. It's actually very often build it once, and you can use it on in many different container platforms. So we can do something similar to what we did before. I'm going to go back into my Dockerfile here, to my Docker location. Before we had this Dockerfile, we can jump into now and see Singularity. Singularity is typically used in shared file systems and sort of shared environments for running an HPC. So it's designed really specifically for this. There's a couple of differences with Singularity versus Docker. The main one is that it's not running as a daemon. So Singularity is a file, and also the Singularity image is a file. So it has this .image format, which is basically a single file itself that you don't have to worry about having this daemon running all of the time. And you don't have to worry about this kind of elevated privileges itself. Very much like with a Dockerfile, you also have a Singularity file, again with a capital S here. And here's an example of the exact same pipeline that we built before, or exact same container we built before. But in this case, using Singularity. So we can say, spin this up. I'm just going to go use Vim in this case. So Vim Singularity. And I'm going to paste this inside here. So let's go back and copy this. This bootstrap is like the same as having a base image. So you're seeing a base image of Debian. We're changing the environment first. In this case, we have some labels, some metadata, and then we've got our command, which is going to download Salmon and run that. And when we do that, you can see that we can use a very similar command as well. So we can, instead of saying Docker build, we can use Singularity build. Now, one of the slightly annoying things is that to run Singularity, you'll often need sudo. So obviously to create, this is just to create the image, I should say, when you build it. There's a bunch of sort of specifics around this, what's required here, but in the basic sense, we're going to say sudo Singularity here, and then we can say the build command. And now we're going to specify, instead of giving it like a repository ID, we can actually just give it an actual file name. So we can say my image .sif, Singularity image formats, and then we're going to point it to our recipe, our Singularity file. And when we do that, I might have made a mistake in the pasting of this. Got a feeling? Yep. Just confirm what that looks like. It should be Bootstrap. Okay. We run that through, and it's very similar. You see all the different steps which are going through, unpacking the layers, and launching that there. To run the file, there's two different commands for running the containers. One of them is like exec, which is really just kind of the execution of that. Then there's also the shell command from Singularity, which is really the same as the interactive mode with Docker we saw before. And for running that, and just wait for this, this takes a couple of minutes to launch through it. Here, I can show you in practice here. In terms of running the containers here, we have got this exec mode, which is the same as Docker run, and the shell mode here, which is the same as interactive that we have before. And the important thing is that when we touch, for example, if we go inside that container and we say touch hello, that file will be created as us, as the host, not as like inside some special container user space as well. Same thing around the mounting of the files, that often you'll see Singularity will automatically mount the home directory. This can be useful for some things. All these things can be controlled as well from the way the Nextflow works there. The really cool thing though is that this is kind of around this interoperability. So you can import a Docker image into a Singularity file, which makes it fantastic. It means that you as a developer of a workflow where you create this can really just focus on creating Docker files. And then you're able to get it to run. So let's say, if we look here, if we want to then go run this, just to show you the commands for running that, have the ability to do shell exec. So if I jump inside this container now, inside the SFI file, you'll see that there's just some command prompt errors here, but you can ignore these. These are something specific about the VM that we're using. If I touch this file, so now I'm inside the container, if I touch this file and say, okay, hello.txt, you can see that I'm creating this file. If I exit now, or if I do ls away, here you can see that the file has been created, and it's actually as EC2 user. It's actually as me. So if I exit here and contain here, just do ls, here you can see that that hello.txt file is there. So it's mounted that directory where I'm working. And you can see that the permissions for it are from Nextflow's perspective, how do we do that? Well, given the fact that we can do things like pull a Docker container using Singularity. So I'm going to say the same thing, Singularity pull, but now I'm going to point it to our Dockerfile. So let's just say our Docker location. Now to do this, you should specify first that it's a Docker image that we want to pull. So Docker pull here, specifying that this is the exact one we had before. You could even do this with my image or whatever one you're creating. And you'll see it's going to do this conversion here. So unpacking that into a Singularity file, which can be run. And from Nextflow, in terms of how you can use that, we can do a very similar command, except instead of saying, let's go back to the top. If we want to say Nextflow run, we can then say, for example, script 7 here. I should jump back up. Okay. Yeah, if there's an error, someone maybe just make sure that you are in the right directory when you run this bit, back in the environment, back in the base directory. Otherwise, you won't be able to find the file. So Nextflow run here. I'm going to say script number 7. And now I'm just going to say, instead of with Docker, I'm going to say with Singularity. It's far too long of a word to typing all the time. And then you can point it at even a Docker container. So Nextflow -RNA-seq. And this now is the Docker image that we're running. So we're pointing at that location. We'll run through. And here I'm getting this error that say cannot enable more than one container engine. I'm trying to tell it to use Docker and Singularity at the same time. The reason for this is in my Nextflow config, I have this, you can see it's above here. I'm trying to give it too many options. So let's save that. Oh, I was trying to write that in 2 places. Let's just remove it here to be clear. Save that, and then launch again. And you can see that this will now run through. You can see that when you run with Singularity, because those are files now, like image files that we're creating, Nextflow has to place them in a location. And by default, it's going to place them in your work directory under work Singularity. So if you go into here, you can see work Singularity. That's just basically going to be the location of that. And those are cached as well. So it's not going to pull it in every time. It's only going to create one version of it. And this is nice. It means that you can almost have a shared working directory with your colleagues, with people in your team who can all access those images as well. The rest of the process is exactly the same. So it's just going to run through. Instead of it now, Nextflow being a Docker run command in terms of what's inside of the command.run file, it's going to be a Singularity command. Obviously just running that in the same way. And there's a bunch of different options on how you can run Singularity there as well. I want to point out one, and that's kind of goes around Conda. And Conda is an alternative for using containers. It's not container engine per se, but it has some really nice built-in features that we can leverage, particularly for building containers. And here is an example of how you can use it in Nextflow. You can call Conda itself, so you don't actually have to turn it into a container first. You can just specify a YAML file with all of your Conda environment, and then from there you're able to use that. So this is a way of saying, instead of with Singularity or with Docker, you can say with Conda, and you can point it at that environment. Here's an example of the same pipeline that we had before. You have a way, a little bit like Docker images, of viewing these Conda environments. You can activate them here. And with Nextflow, the key thing is that we can say Nextflow run, point it at our script, and we can say with Conda. Now, the Conda environments can be maybe a little bit more difficult to manage in terms of reproducibility, because they're kind of installed and they're not so easy to pass around like we do with the files, which are our Docker containers, which are in Docker Hub. But there's a really kind of powerful thing about them. And this is, we can define the Conda environment inside of our container. And what this does is it means that we can have a Conda environment, which is very easy and very quick to build all of the tools. It handles all the dependencies, gets everything managed. But with the advantage of having it in a container in Docker, which means that someone can also run on Singularity as well. So we basically provide all the options within a single way of doing this. And I'm going to go into now the example of the RNA-seq pipeline we saw before and just show you what this looks like in practice, and something that you may want to consider when you set up your own pipelines. Now, I should also provision them and say, the way that we are building this containers are all of the software is in one container. And depending on how many steps you have in your pipeline, it's probably not the best way to go about it. If you have more than 2, 3, 4, 5 pieces of software, you start to get to a point where maybe it's better to have a single container for each process, for each piece of software. But this is kind of all together, trying to be a simplified version to show you how it works. So inside this repository, we place a Docker file here. And the way that this works is that we have a Docker file itself, and the Docker file is very minimal. So the Docker file is pretty simple here. You can see we're building from a Conda base. And all we're doing is we're copying over the Conda YAML. I can make this a little bit bigger for you. We're copying the Conda YAML file, and then we're basically running a Conda environment update, building the Conda environment inside the container. And what this means is it means that we can get all the software from Conda, but it's now inside a Docker container, and we can pass around that Conda container just like we would our containers before. And if we go back and see exactly what's inside of that Conda file that we're copying here, so this is a Conda YAML, we also have that. It brings the kind of all-in-one way of providing multiple ways to run the same pipeline with different container engines in different ways. And what I was mentioning before, it's very often you'll see, like in the NF core pipelines, the idea that we've kind of split these things into modules now. So each process becomes a module. And as part of that, you can define how the container is built with its own way, and you're kind of pushing those things to registries automatically for running as well. Okay, there's another exercise there I can leave you through over the next day or so. So there's an exercise there about building your own alternative. So Conda can sometimes take a long time to build. You'll often see that it can take a little while to run there. So we put an example of how you can use this micromember. It's such a small version, a fast version of building Conda environments here. So here's the name that we have, so slightly different in terms of the Conda one, but the main command is the same. So this is a Dockerfile with micromember installing this different channels and the software that we want. And all of that goes into a single container, which you can then try. And if you want to kind of get some experience with this, you could try create this container, and then you could even try push it to your own Docker Hub and then specify that as the input for the pipeline itself. There's some steps here that if you want to go through this, it may take a few minutes as well. Obviously, there's biocontainers. Biocontainers is a collection of building those containers automatically from Conda files themselves, or from Conda packages. So if you go onto the project here, you can find the list of all of the kind of Conda packages which are automatically built into containers. There's some advantages to this in the sense that they're kind of off the shelf. There's also some disadvantages in the sense that you can't really customize it yourself, or imagine situations when you need to have some tool and then you want to pipe that to SAM tools, for example. Having kind of multiple pieces of software inside of the container isn't always necessarily possible. There is some approaches to kind of do this in terms of what they call null containers, building those things on the fly. We're quite active in terms of coming up with solutions for this at the moment, and trying to think of ways to make this really nice and easy. So ideally, you can just specify the software you want, and the container process can all begin kind of automatically as it runs through it.